Welcome everyone to our session, which is called Delicious Science Snacks with Zeke and Desiree. So my name is Dr. Desiree Whitmore. I am physicist in the Exploratorium's Teacher Institute. I've been here for about 2 years, and this is Zeke.
Hi, I was a high school physics and environmental science teacher for 21 years before coming to the Exploratorium.
He's kind of a show-off because he's amazing. So we are doing some great activities for you that come from the Exploratorium's Teacher Institute, some things that we actually like to call science snacks, and we'll share a little bit more about that information about that with you a little bit later on. And right now I'm going to share my screen because I created a presentation for you with all of the resources that you're going to need to follow along with what we're doing. Now, Zeke and I are both on social media, so if you do happen to use social media, please feel free to tag us. I'm Darth Science on Twitter, and Zeke is Z Kossover. Also, the document that we're going to be using is called, it's at tinyurl.com/delicioussnacks-ti. Feel free to join it right now. If not, then PocketLab is going to send it out to everyone later on. And also, I've noticed a lot of great posting on social media today throughout the conference. So I've seen a lot of the ScIC Conf hashtag. Please feel free to also use ExploEDU hashtag for all things Teacher Institute, because that's how you find us across all social media channels. Now, before we begin, even though we are not at the Exploratorium, we're in our respective homes right now. The Exploratorium is our science home, and I just want to acknowledge that it is on Ramaytush Ohlone land, and I would like to pay respect to the elders, both past and present and future, who have cared for it. If you'd like to learn more about the Ramaytush people, feel free to go to ramaytush.com, or if you want to learn more about the lands that you occupy, please check out native-land.ca. Now, the first activity we're going to do is super fun. It's called Cleaning Pennies, and as I mentioned, I have this document for you that you can access. I'm going to stop sharing now, but this document shows a link that you can click on to actually read all about the activity. So first off, I'm going to use Zeke's amazing, Zeke is going to be my Vanna White, and so I'd like you to pay attention to his video, which means maybe that he should be talking, except he's not. So on his video, what you'll see is he has 3 separate bowls and a bunch of dirty pennies, right? So this activity, we came up with this activity because we were challenged with this idea of everyone having to be at home, right? Normally, when you're in a classroom, you have a lot of control over how your kids are doing their science and what you're teaching them. And now they're not in your classroom. So we were trying to think about how can we turn this into an opportunity to really think about how to utilize all of the resources that these kids have in their diverse homes, right? If you have 30 kids in your classroom, then you have 30 different homes and 30 different opportunities. So Jason Lindsay was just talking in his presentation about the importance of variables in science experiments and having kids try different variables. And so we thought every kid has different things in their house that they can try. So this is a chance for kids to really contribute to the scientific community that is your virtual classroom, right? They can help guide the explorations in the classroom from their home, so they can have things that are different. So for instance, what we have, I have a bunch of different condiments. So I like this experiment because you can use up these condiments that are in your condiment drawer. I have a ton of these that I don't use. I don't like ketchup. Here's some hot sauce. Here's some more hot sauce. And so what Zeke has here is 3 separate bowls. One has vinegar. One has vinegar with salt in it. And one has ketchup. And he's going to drop a penny into each one. And you see he's got 2 pennies in front. And that's just because he's got 2 pennies that are similarly dirty, basically, okay? So while those are sitting there, I want you to pay attention and watch what's going on. And I'm going to talk us through what's actually happening via chemistry. So, you know, as many people know, pennies are copper, but post-1983, pennies are actually just coated with copper. And so that copper coating over time reacts with oxygen from the air, and those pennies actually start to turn brown. They start to form copper oxide. So for instance, I have this really dirty penny here. This is all copper oxide. And so what happens in this vinegar has acetic acid in it, and acetic acid attacks that copper oxide. And when it does that, it actually breaks up the copper and the oxygen into ions. So now you just have this, you have the copper ions in solution.
Desiree,
yes.
can I interrupt you for just a second so that they can put the camera on? Hey, folks, can you put the camera on the Zeke Kossover one for a second?
Oh, yeah, you can pin Zeke's video.
Great. Thank you.
Excellent. Thank you, Zeke. So there's copper ions and there are oxygen ions sitting in your solution. And what the vinegar does is it keeps reacting with those ions and it keeps attacking the penny. But once you add salt to the solution, the salt occupies those copper ions so that the acetic acid can continue to attack the pennies. So it happens at a much faster rate. So if you look in Zeke's, on Zeke's screen, you get to see these 3 different pennies, and some of them are changing faster than others. And it's really nice because, yeah, you can see they're actually starting to become much cleaner and more like the penny at the top, which is a brand new penny, right? So after they've been in there for a couple minutes, all you do is take them out and you put them in some water to rinse them off. You still cannot see it? I'm sorry. So you click on the 3 dots. When you see Zeke's video, you click on the 3 dots there and you say pin video. Does that not work for folks?
They say they can see it now.
Okay. We don't have those dots. Better. Okay. See when, okay. So yeah, go to gallery view. It's probably easier because then you can see us side by side. Okay. So Zeke pulled out his pennies. He's going to pull out the pennies and rinse them in water and show us what they look like afterward. So basically all we've done here is create these super clean pennies, which is fantastic. And you can see the pennies next to them were the same, those 2 pennies were the same color before he popped them into the solution. And now they are different colors. Now the ketchup penny is awesome because Zeke stuck it in only part way. And so you can see how clean it got on the bottom and the top is less clean. And that's ketchup. So why does ketchup work? Well, it turns out that if you go in your ketchup drawer and you find all of your different condiments and you look at the ingredients, they all have some common ingredients. And those common ingredients are salts and vinegar. So all of this chemistry that I just explained to you, you can do with just ketchup packets or hot sauce packets or mustard. And you can try a bunch of different things. So this is where having kids be able to pick their variables becomes really, really powerful. And so here, you have something to say, Zeke? Okay. Here, I'm going to share my screen one more time to share with you the results that I've done with several different solutions. So I did it with water. I did it with vinegar. I did it with salt and vinegar. I did it with bleach, lemon juice, hot sauce, ketchup, and OxyClean with water. And as you can see, on top, I've got my before pennies, and on the bottom, I've got my after pennies. And so ketchup, hot sauce, and lemon juice worked really, really well to clean my pennies, right? And again, this is because of this salt and vinegar solution. Now, lemon juice, of course, is not salt and vinegar, but it is still acidic. So lemon juice has citric acid, which is a stronger acid than acetic, and it does the same kind of thing to attack the pennies. And if you add salt to the lemon juice, it works even faster. Now, Zeke and I really love this activity for several reasons. And one is you can really allow kids in their own homes to think about how to challenge themselves, right? How to challenge themselves further in this experiment. And so they get to choose their own adventure, kind of, right? And so by doing that, they're more motivated to continue the research. And so they can think of their own different challenges, like how do I clean the pennies the fastest? Or how do I make my pennies the cleanest? Which solution is going to work the best? And another interesting challenge that works is thinking about data analysis, right? This is one of the science and engineering practices, thinking about data analysis and computation and how to communicate your evidence. And so we thought kids can actually really think about, depending on what their challenge is, what's the data that you need to collect right? They have to think about that. They have to think about what the data to collect is. They have to think about how to collect that data from the entire class, because everyone in the classroom is going to be doing different challenges. And then, of course, how to present that data. How are they going to take this data, present it to everyone else so that they can either refute or support their arguments? And this is a great experiment because we can do more science with it. So I mentioned that there are a bunch of copper ions lying around in here. So once you remove the pennies, the copper ions actually stay. And what you can do is you can throw some nails in there, like some steel nails, and the same chemistry will happen to the nails, and it will replace those iron ions with some actual copper ions. So you can have steel-plated nails. Or you can form malachite, which is this green, kind of crusty, beautiful patina that you can get on top of pennies. And that's actually why the Statue of Liberty is green. And to do that, all you got to do is throw in a paper towel into this solution and then put your clean pennies on top and let it sit there for a few days. So again, this is a way for you to have your kids come back every day and really kind of guide the whole exploration so that we're actually turning this opportunity, turning this event of having kids at home instead of in your classroom into an opportunity to really have them contribute in a diverse way. And so now I'm going to stop sharing my screen, and we are going to have Zeke talk about another amazing snack that we have. And I'm not even going to say the name of it. I'm just going to hand it over to Zeke.
Hi, so we call our activities science snacks because they're small activities. We're not writing an entire curriculum for you. We're giving you activities that you can use as you see fit in your classroom. But what I want to do right now is I don't want to talk to you looking at the camera. I want to talk to you from Mirrorland instead. So here I am. Now, can you all see me here in Mirrorland? What is it saying on the chat? Yes, fantastic. So you all can see me in Mirrorland. And in Mirrorland, I'm exactly the same person that I was in Cameraland, except for one small difference, which is the writing on my shirt seems to be backwards. In Cameraland, my writing seems fine, but in the mirror that I have propped up on this lovely card catalog that no one needs anymore, so you can totally get them for dirt cheap. And you can see that the writing, though, on this mirror is backwards in Mirrorland. And that's the question all students have about mirrors. They don't care about anything else. They just want to know, why is writing backwards in a mirror? And if you go on the internet, there are so many explanations about this. My favorite one of which is that you have two eyes, and the eyes are horizontal. And so if you close one eye, that's why it's flipped left to right instead of up and down. If your eyes were one on top of each other, they'd be flipped upside. That's not what happens, right? If you close one eye, still looks backwards there. So there's something very weird about mirrors, that they reverse things left to right, but not up and down. How does it know left and right? Well, let's look at what's different between me here and the me in Mirrorland, what he does. So I'm going to point first to the left. Left, that's complicated, right? It's hard to figure out whose left I'm talking about. So this is in my house, and it turns out that that direction is west. So I'm just going to put a little sticker here so that you'll know that that's west. And I'm going to point to the west. Which way is Mirrorland Zeke pointing? He's also pointing to the west.
West.
If I point this way, well, that's east. Which way is Mirrorland? Desiree, which way is Mirrorland Zeke pointing?
East.
He's pointing east as well. That's weird. I thought things were reversed in mirrors. Like if I were to, I point west, it points west. Mirror me points west. I point east. Mirror me also points east. It's strange. Let's try up and down. If I point up, which way does Mirror Zeke point?
Up.
He also points up. And if I point down, which way does Mirror Zeke point?
Down.
Down as well. It's very strange. Everything in the mirror, Mirror Zeke does everything the same as real Zeke does. wait a minute, we haven't tried all the options. My students would be yelling at me through Zoom. You all are very polite. We've actually got you turned off, so you can't yell
What
at me.
about north and south?
That's what they always want to know. If that's west and that's east, they want to know what happens if you point north or south. So let's add north and south to this. Here's north and south. If I point north that way, which way does Mirror Zeke point?
Oh my gosh, you're pointing south.
Wait, Mirror Zeke is pointing south. And if I point south, Mirror Zeke points
North.
north. That's where the symmetry is broken. Mirror Zeke does something different when I point into and out of the mirror. It's not left and right that are getting reversed. It's back and front that's getting reversed. We're swapping this way for that way with the mirror. The problem is that we don't understand what it's like when you swap front to back. That's just so confusing for us. We don't, have an intuition about it. So let's do something with and try to come up with something where we can get a little bit more intuition. So if you write on normal paper, you can't see what it looks like if you're writing on from behind. So the activity that we have linked online tells you to use a transparency and write on the back of it on a transparency to look at it from behind. But who's got transparencies at home? And in fact, who has transparencies at all anymore? I mean, I don't have an overhead projector.
I don't have any.
No. We live in a modern era now. But it turns out that I own a Ziploc bag. And you can write on a Ziploc bag with whatever fun saying you would like to put on it. And then we can turn the Ziploc bag over to see what it looks like if you see writing from the back side. And what does it look like when you see writing from the back side? It looks like what it looks like in the mirror. Because when you write from the back, when you look at letters from the back, that's when they look upside down and backwards. In fact, I didn't even have to write on this bag because it turns out Ziploc already did for us.
They're so great.
They are. It's super handy. In fact, last time I went to the barber shop,
Nice.
They had writing on the window that was on the inside, looked flipped left to right because I was seeing it from the back side of the writing. And so that leads us to one final activity that's along those lines. I just took more of my Ziploc bag and I made something very large on it so that we could see it in the mirror as well. So here's sort of a tape F.
It's a giant F for fun, for physics.
Giant F for fun, giant F for physics, frankly. Every other language, physics is not a PH, it's an F. Anyway, so in a moment, I'm gonna take this piece of the clipboard away so that you can see what this F looks like in the mirror. And when you see what the F looks like in the mirror, I want you to make a prediction right now what you think that's gonna look like. Will it look this way? Will it look the other way around? What's this F gonna look like when you see it in the mirror? So
you're gonna be holding it. You're gonna be holding it facing the mirror.
I'm gonna hold it just like it is right now. I'm just gonna take the clipboard away.
Okay.
So all I'm gonna do, I may move it just a little bit so it's easier to see. I'm gonna put it over here so you can see it in the mirror better.
Some people say backwards.
We have some people say it's backwards.
Some people say flipped.
Some people say flip. That sounds like
same
backwards
as we
again.
see it with camera view, which means
same as
right
we see it with
way.
camera view, so it's not going to do
So
anything.
same regular flipped forward.
Flip forward.
It will be the correct way.
The correct way.
That's a great answer. Up and back.
My students hate the fact that I use the letter F. They really are afraid of Fs, but they're so handy in this case.
Yes, Fs are
it's really
actually
easy to
perfect for
see
this.
which way it is.
So right to left, upside down, PH.
There's so many places.
Someone says you're going to see a PH in the mirror.
I love the PH in the mirror. All right, ready to give this a try? Let's take off the clipboard and so you can see it in the mirror.
What?
It looks right in the mirror. That's because I want you to think for a second, but I shouldn't tell you the answer. You think for a second about why you think it's gonna look, it still looks normal in the mirror. It looks like easy to read. right? If
Backside of F.
the
Does it look like the
mirror
backside
is
of F, or does it look like the forward side of F?
in the mirror, I think does it look like the forward side of F
Yeah.
to you, Desiree, in the mirror?
I think it
Yeah.
looks like the forward F to me.
It does to me too. It looks the same as the one here. And I think it does that because the mirror is seeing the backwards F, the backside of the F. And then the mirror swaps back to front again. And so we see the F back the regular way. And that's what mirrors do. Mirrors don't swap things left to right or up or down. They swap in and out. And that is what makes writing look so weird, because you see it from the back side. Yay!
Hey, thank you, Zeke.
This is one of more than 300 online activities the Exploratorium has. They're all free, and they were written by physicists and other PhD scientists like Desiree, and high school and middle school science teachers like me. And we try them out in classrooms, and we try them out with bunches of teachers before we put them online, so that you will know that they work fantastic and they will be perfect for your classroom. And we have them in all different disciplines, and we'd be super excited if you were to come to the Exploratorium and come to our website at exploratorium.edu and see the materials that we have, that we would just be thrilled if you were to use them.
Yay, thank you. I'm putting the link into the chat so that people can find the snack link.
Yay!
Okay, that didn't work. I don't know how to put links into the chat. Clearly, I'm not good at this.
Luckily, if you just put Exploratorium into your Google search, it's going to find us. There aren't very many other Exploratorium.
Yes. And it's pretty great because not only do we have our snack page, but we also have a page with snacks that are dedicated to COVID-19 education. And so that is called our Learning Toolbox, which is at exploratorium.edu/learn.
Absolutely. So yes, we have a wide variety of materials available there. Ones to help your students understand, or your children for that matter, understand the specific nature of COVID-19, how soap does its thing, to like why is washing your hands so important, how something that has so few, literally just so few atoms can be so much trouble, like how it convinces your cell to do things, how it reproduces, how it self-assembles, even though it has so few instructions to it. We have a lot of that, and we have all the sort of things that you might need for science for next year. And we have all the explanations from them, and we also have the materials that you need to get. Desiree and I came up with, I think, 75 activities that almost everyone is going to have all the materials already in their home, and then the rest of the stuff online has a variety of different things that are some of which require a whole lot of construction, and maybe if you're into that, that will work for you. And then other things that are super simple to put together, just like this.
Yep. Thank you, Zeke. And so, yeah, we would be glad to answer any questions that you might have for us or the Exploratorium.
And, you know, I got to tell you, that mirror was amazing. I think you won the award. We don't know what the award is, but whatever it is, so far you won it.
Actually, Mirror World is such an odd place.
That was really, really cool. And the explanation and the activity, people were going crazy with it. It was really, really cool.
Excellent. Yay.
Yes, yeah. So you're, we actually do have a award. We have a golden PocketLab. I think you're going to win the golden PocketLab award. We actually have golden PocketLabs.
Woo!
I don't know.
You don't know how much you just made Zeke's day. He loves PocketLab, and he loves tinkering with things. So, like, we're going to get to use it in our workshops. It sounds so much fun.
Oh yeah, just send me a message. We're always happy to. There's PocketLabs up there, but I think everybody's hoarding them, so you probably can't find them.
Well, yeah. I would say that the people in our Exploratorium shop actually use them quite frequently for testing and prototyping for activities. Now, we don't embed it in any of the exhibits, because then we wouldn't have the PocketLab anymore. So but we'll use it for prototyping, and it's fantastic for that.
Yeah, sure. Whenever you need, whenever you need something, just shoot me a message. We're happy to help out. It's great to work with you guys. That was just amazing. I saw a lot of people asking for links and stuff. So by the way, you guys do these webinars, right? And they're on the site.
Yeah, so if you go to exploratorium.edu, and I think the click is educator, it'll bring us to an educator page, and there's a place to sign up for an educator newsletter. We will send you about one message every 6 or 7 minutes. No, I promise. We'll only send you about one email a month. And it will have links to other teacher activities that you can sign up, teacher webinars that you can sign up for. Some are just a few real short like this. Others are an hour and a half long, where we go through like some very specific ways of like places where you can run into trouble when doing an activity in your class. And indeed on our line, when you look at our activities, many of them have teacher tips or other suggestions for how to make it work successfully in your classroom.
Yes, but I would also like to mention that I would not call what we do webinars, because webinars kind of imply that you have somebody talking at you all of the time. And even though that's kind of what we were just doing right now, that's not the way that we normally run our workshops. All of our things, we call them workshops because they are very hands-on and very engaging and very interactive. So we often use the utilization of Zoom and all the things you can do in Zoom, like breakout rooms and the chat, to really have people interact with us. We want everybody's camera on because we want to see your faces. We want to see what you make, just like we want to see your clean pennies and things like that. So I would not call them webinars. I would call them workshops. But yes, we've got a ton of them.
Yeah, Desiree's right. The last time we did this one with the pennies, we actually mailed out packets of materials to make sure that everybody would have materials to do these activities, so that they can have the experience of them. And we tried to figure out what's the cheapest way to mail stuff, so that we try to only have things that students would have in their house, but maybe you still have a couple of students who don't have anything. Like we wanted an eyedropper for an activity, and we're like, most students can probably come up with something eyedroppery, but maybe you have 10 students who still can't. Is it possible to send an eyedropper through the mail, like a plastic pipette? And the answer is absolutely yes. You can send it through the mail, and you can then outfit the last few of your students who don't have everything. And that's really, I think, a kind of an equity focus, which is that you don't have to give up on an activity because there are a few of your students who can't do it. You can help those students who don't have the capacity, so that everyone can have the highest level of education that you can come up with.
Got it. That's great. Hey, there's a couple of really good questions here. One quick might be hopefully a simple one. What's your favorite science snack activity?
My favorite science snack activity is a thing called modulated LED, which shows you how you can transmit sound by light and then decode it later on. It's a little bit more involved activity, so I don't have it set up for you today, but you can see it online, and it even has a video so you can watch how it works. It's called modulated LED. Whole thing costs, when you buy the materials, about $20 to make.
Sweet.
Desiree, what's your favorite?
My favorite snack, I have two, but I'll just tell you one. One of my favorite snacks is soap film in a can. Basically, you have an old film canister or some dark black thing that's open, and then you have a bubble film, and you create a soap film on the surface or on the open end of this canister, and you can really see light interference. So you can see positive and negative like color interference. So you get to see these beautiful, colorful rainbow lines falling down the surface of the soap film. That's my favorite. And it's super cheap.
That is so cool. Just one, I wanted to, so I don't want to get in trouble. I'm taking everybody's break. If you're mad at me, chat at me and I'm watching. I'm so sorry, but this is too interesting and there's too many good questions. So I did just a quick minute or two. There was a great question we got in the last Science is Cool conference, and that is, kids are tempted to Google the answers to these. And how do you deal with that?
So our main thing when we're doing activities with students rather than perhaps with teachers is that we don't ask them, how does this work? We ask them, what do you notice? What do you see? Or what did you experience when you did the activity at your house? And then after that, as Desiree says, what do you wonder next? What's the next activity that you can do with it? Because when I was a teacher and I gave tests, my test answers weren't just what's going to happen next. My test questions are, and why do you think that that's true? What evidence do you have to support that rationale? And I think that that's the most important thing that we ask from students. It's very easy to ask on a standardized test question, what's going to happen in this situation? Is it going to be inverted? Is it going to be a real image? Is it going to be whatever? But instead, if you ask students like why it's going to be that way, and sometimes that makes it harder to write a multiple choice question, and I guess I have some feel for you, but I had hundreds of students as well. You have the opportunity then to like get into their knowledge. And so even if they've looked up the answer, I want to know the explanations, the evidence, the reasoning behind that.
Very cool. I think it's a great, people are liking your answer. I think that is the right thing too. And that's kind of, so Paul Anderson got asked that question, and very similar to his reply. It's like, hey, well, you know, and he also, you know, encouraged them to think about, hey, look, if you just Google the answers, you know, you're not learning anything. And when it comes to, you know, doing a test or an assessment, you're going to fail because, you know, you're just not going to know how to evaluate these things. And you're not going to have done it.
Well, and you know, this is really in the blood of the Exploratorium. Like, we're being beaten down really hard at the moment because we're a hands-on kind of place, and no one wants to be in a hands-on kind of place at the moment. But like, the Exploratorium doesn't tell you the answers in all the exhibits. They want you to explore so that you learn something and figure it out. We're like, lots of science museums have like long, detailed explanations all over the walls, but there's nothing for you to touch or do. Those can be, if you already know the science material, boy, does it feel good to see that kind of science explanations there. But if you don't know it, it is a hard way to learn it. Whereas if you can touch and interact with it, that is a way that you can learn not just for the minute, but for the rest of your life. And that's our goal.